Okay, Assalamualaikum warahmatullahi taala wabarakatuh, and a very good morning to all of you guys. Okay, thank you for joining our online class for today. Okay, so today we'll continue on our next lecture on reinforced concrete slab design. So before that, I hope that you already know how to design a slab. So if you have any problem, as usual, you may text me. Okay, so for today, for your class, so we're going to go on the example. Okay, straight away on the example for uh, simply supported two-way slab. So this is a difference between a one-way slab. So what we will see, what are the difference between one-way slab and also two-way slab. Okay. Everyone can hear me, eh? Oh,
Can, sir.
Boleh, sir.
Boleh, sir.
okay. I'll share my desktop first. Okay, all of you can see my notes, eh?
Boleh, sir.
Oh, this is a continuous, sorry. Simply supported two-way slab. Okay, here are the example for simply supported two-way slab design. So as we know that, okay, this is a simply supported two-way slab design. So where the slab is not connected with another slab and it is supported by simply supported beam. Okay, so you should know how to transfer the load for simply supported two-way slab or one-way slab. It is same. Okay, so okay, so in our beam design, we already learned how to transfer the load. So for the slab design, so we will not transfer the load to the slab lah, because all the load is start from the slab. Okay, so the first one, this is the information given. Okay, so the first one, you have to determine either the slab is a one way or two way. So by calculating the ratio with Ly over Lx. So here Ly over Lx is 1.6, is less than 2, therefore the slab is a two-way slab. So next process, we have to calculate the C nominal, which is equal to C minimum plus C deviation. So due to the fire resistance, due to the bond requirement, and due to the exposure condition. So we have a look on determination of alpha for two-way slab here. So refer to your design appendix. Okay, by referring to this design appendix table 5.8 here. Okay, so how are we going to determine this alpha? Okay, we see the ratio, okay, of the Ly over Lx is equal to 1.6. So therefore, it is in between 1.5 and also 2. So if the value is less than 1.5, you will use this value. Okay, the REI is equal to 60, and then therefore your alpha here is 15. Okay, so that's why I got the answer here. Alpha is equal to 15 minus with diameter bar over 2. As usual, if the diameter bar is not given to you, so you have to assume the value is 10. So if, for example, the value of the diameter bar given to you, either it is 12 or 10, you have to use the given value. So again, if it is not given, you have to assume the value is 10. Okay, second one is due to the bond requirement, equal to C minimum B by referring this table 4.2 equal to diameter bar, which is 10 millimeter, and then C minimum durability, as usual, we have to refer to this table. sorry, the exposure, okay, the exposure table is not here. The exposure class table, okay? So the exposure class table, and then you determine the C minimum durability, because the FCK given here is 30, okay? The FCK given here is 30, so we have a look on the design appendix. Wait for a while. Okay, design appendix, because the given is the given table is XC1, okay, XC1 or XC2. Okay, XC2, so that's why you using the value is equal to 25 here. Okay, 25. Okay. Okay, so you got the, by comparing these three value, you get the minimum is equal to 25, and then plus with deviation 10, and then you get the C nominal is equal to 35 millimeter. Next, we calculate the design action as usual. So the design action, the information given here is, okay, permanent action is come from the slab surface itself, and then ada variable action here, shielding, and also services, and also finishes here. Okay, you have to remember that when the slab thickness is not given in your question or in your solution, so because normally the slab thickness is not given in the architecture drawing, therefore we have to determine our own slab thickness by using the span over depth ratio, or we use a fire resistant ratio by referring table 5.8 and also table 7.4n. Okay, so as we can refer to this table, okay, by referring table 5 point, this table, okay, by referring to this table 5.8, okay, we know that, for example, the minimum fire resistance for 1 hour, okay, the thickness is 80 millimeter, and then you have to calculate also depend on span over depth ratio here, okay, table 7.4n. So in my previous note, I do already shows you 7.4n, which is a table for slab, table for span over depth ratio. Okay, so you compare both value and then you get the maximum one, and then you determine the slab thickness. So in my case here, the slab thickness is already given. So therefore, to calculate the permanent action is equal to the slab surface 25 times 0.125, and then finishes shielding services, and then the total permanent action is 3.925 kilonewton per meter square. Let it be in kilonewton per meter square. And then the total variable action, as I do already told you before, okay, we have to determine the total variable action based on the slab condition or based on the building type, which category under this building. So either it is a residential, either it is commercial, school, classroom, laboratory, and then you have to determine based on the national annex what is the total variable action QK. Okay, next one, we have to design the action and okay, actually design per meter length. Okay, design per meter length. Okay, so n equal to 1.35 GK. We factorize the load 1.35 GK plus 1.5 QK, so we get 9.05 kilonewton per meter square. Then we design per meter length n equal to 9.05 kilonewton. As usual, we have to draw the shear force and also bending moment. So here is the difference between the shear force and also bending moment for two-way slab simply supported. So for shear force is same as an equal to n Lx over 2, but for the bending moment, there is two direction bending moment, which is at short span and also long span, because it is a two-way slab. Okay, how to determine this bending moment? Okay, by referring this design appendix. Okay, table 3.13, bending moment coefficient for slab spanning in two directions at right angle, simply supported on four-sided. Okay, so you have to use this formula. For the short span, MSX is equal to alpha SX and LX square. MSY is equal to alpha SY and LX square. So in my case here, you have to determine your Ly over Lx. So in my case here, our Ly over Lx is equal to 1.6. It is in between 1.5 and 1.75. So the value for the alpha Sx is in between 0.104 and 0.113. So what you have to do, you have to do an interpolation to get the actual value for the alpha Sx at Ly over Lx equal to 1.6. You have to do for both. Okay. So we back to our example here. So I got the answer here. Alpha S is equal to 0.108. Okay, time 9.05, which is the design action, and then the Lx 3.75 square. I got 13.74 kilonewton per meter square. We do the same process for MSY, and then we get the alpha SY is equal to 0.042 times with 9.04 times 3.75 square. We get the answer 5.35 kilonewton per meter square. Then here are the different when we would like to start the design main reinforcement. We have to design main reinforcement for both axes. So normally for slab, we will design a reinforcement based on how many numbers of moment that we have. So if we have one moment, we only design only one main reinforcement, and then we provide the secondary reinforcement. If we have two moment, we will design two main reinforcement, and then we provide one secondary reinforcement. Okay, so the effective depth for two-way slab, okay, so we have to calculate for both axes dx and also dy. So dx is equal to h minus c nominal minus 0.5 diameter bar. Okay, so 125 minus c nominal 35 minus 0.5 times 10, we get the answer 85 millimeter. So dy is equal to h minus c nominal minus 1.5 diameter bar, then we get the answer 75 millimeter. So this is a slab. So we don't have a link for slab. And then we calculate the AS minimum and also AS maximum. Don't forget to use B here as 1000 millimeter. Okay, and then we provide the secondary bar as I already told you before by using this AS minimum, and then we provide H8 300 center to center 168 millimeter squared per meter. So we can use 8 millimeter as a diameter bar for secondary bar. And then we have to design both, okay, directions, short span and also long span. First, we have to design for the short span. As usual, we have to calculate K, Z, and also S, because we design as a rectangular section, not as a beam. We have a rectangular and also flange section. So here are the formula: K equal to M over B D squared FCK. The difference here is only D here, so at both axes. So for X direction or short span, we use dx as the value. Okay, so for long span, we use dy as the value here. Okay, so you have to remember here. So the answer here, okay, as for the short span is AS is equal to 396 millimeter square, which is the required AS tensile reinforcement, which is 396. Therefore, I provide #10 175 center to center, which is 449 millimeter squared. So therefore, the AS minimum here is in between AS provided here is in between AS minimum and also AS maximum. Then we do the same process for long span. Okay, so we check here. Okay, again, I repeat, when we designing a slab, please make sure the compression reinforcement is not required and it's not doubly reinforced. So normally slab is only singly reinforced, and the the compression reinforcement is not required. Okay, so we only designing a tension reinforcement. Okay, for the long span, okay, the AS required here is 136 millimeter squared. Then we provide #10 300 center to center, 262 millimeters squared, and we have to check either the value of the provided reinforcement area is in between AS minimum and also AS maximum. Okay, so if it is in between, so therefore the value that you provided is okay. Okay, next is a design shear reinforcement. So design shear reinforcement or check shear reinforcement, either we need it or not. Okay, so the VED we take from the maximum shear force, so which is 17.57. Okay, so we have to calculate K by using this formula, 1 plus 200 square root 200 over D. Then I got the answer 2.53 is bigger than 2. That's why the K value I use here is 2. And then rho 1 is equal to AS provided over BWD, and then I got the answer here 0.005. Okay, so which is less than 0.02. That's why I have to use 0.005. Okay, so okay, so I got the answer VRDC here is 48.22, and then V minimum here is 46.09. Therefore, VED is less than VRDC. Therefore, the shear reinforcement is not required. Okay, is it correct? So if less than VRDC, shear reinforcement is not required. Can you please do check for me? Okay, please answer me. Don't keep quiet. Okay, betul condition ni VED is less than VRDC. Okay, the shear reinforcement is not required
Okay, sir.
Okay. Okay, I'll continue on the deflection. So as usual, for the deflection, we will use AS AS required. Here is supposed to be AS required, right? 449 is AS provided. Wait. Oh, here supposed to be AS required, which is AS required is 396.
Sir,
Okay. Yeah.
yang waktu simply supported one way for design shear, before this kita compare VED dengan Vmin, sir.
Yes, we have to compare VED dengan Vmin first. Okay, which one is the bigger value? Then we compare with VED. The first
Okay,
we have to calculate VRDC and also Vmin, and then we compare with VED. Okay, so VRDC and Vmin, which one is the bigger one? We compare with VED. So if VED is less than VRDC, therefore the shear reinforcement is required. So I made a mistake here. Okay, at AS is supposed to be AS required 396. Sorry, I will calculate it again. Okay, wait for a while. 396 divided by 1000, okay, time 85. So 0.005. Okay, the answer is the same. Okay, so the answer is same. Okay, okay, 396 here. So here you have to use your dx. Okay, don't use your dy. Okay, for deflection check, dx. So here make some correction. Okay, I'll do the correction later. Okay, so the answer is still same 0.05. Okay, and then we compare, and then we use this. We get the answer. Rho is less than rho naught. Supposed to be we use 7.16b or 7.16a. Can you please do check for me this condition? Okay, we check it together. Supposed to be equation 7.16a, right?
Yes, sir.
Yes, sir.
Yes, sir. A.
So we made some correction for that. Okay. Simply supported to Way Slab. Okay, here is supposed to be 396, right? You can see my
Yes.
screen, right? Okay, so the answer is same. Okay, here is supposed to be equation 7.16 A. Okay, 7.16 A. So wait for a while. Okay, I'll copy the 7.16 A. This one, right? Okay, here is a question for 7.16 A. Okay, the K value is referred to table 7.1, 7.4N, right? So it's equal to 1.0 because it is simply supported. And then our FCK is, what is our FCK? 30, right?
30, sir.
Okay, so our rho naught is equal to 0.0055, and then our rho is equal to 0.005. Okay, and then here is 330, and then here is 0.0055 over 0.05. Okay, so actually, okay, it's easy. If you have your own headphone, actually you can download Microsoft Math. So you just can scan the formula and then you can get the answer. Okay, here are the I'll show you. Okay, here actually the Microsoft Math, nampak tak?
Microsoft Math.
This one, yang tengah ni. Nampak tak? Oh, you tak nampak my camera eh?
Nampak, sir.
Nampak muka saya tak?
Nampak tapi kecil.
Okay.
Kecil.
Nampak tahu pada jelas.
So you boleh download Microsoft Math. So you just scan, okay? If you type everything, you just scan, okay? I'll get the answer very easy and very fast. Okay, the answer is 20.59. Okay, 20.59. Okay, I'll put the value here, 20.59. Okay, the modification of span is equal to 1, and then so we will get the answer for L over D allowable is equal to 23.35. And 35. Okay, so our L over D here is 3750 divided by dx. Okay, we get 44.12. Okay, therefore our L over D actual is more than L over D allowable. Therefore our deflection check is fail. What we have to do if our deflection check is fail, this is my suggestion. Okay, if you have any other answer to make sure that your deflection check is not fail, so you may have your own idea too. solve this problem. My solution is to increase the slab thickness to that effective, so that the effective depth will increase. So means that from 125, I can suggest to 150 millimeter. So if I increase to 100 millimeter, 150 millimeter, absolutely saya boleh increase dia punya D. Okay, so I can increase our the effective depth here. Okay, our effective depth here. So let's say, so if I increase to 150, so 150, okay, 150 minus with 35, okay, minus with 5, so the answer is equal to 110. So 3750, okay, and then 3750 divided by 110 is equal to 34.09. It still fail lah. Okay, so what you have to do, so if it still fail, although you already increase the slab thickness, so because the slab thickness for that area maybe too big, okay, we can reduce the slab thickness, we can reduce the slab area. So means that, okay, for example, okay, so I can input it here, okay, the solution. Okay, contoh dia, okay. So from this slab, okay, we can divide it into 2 section here. Okay, so 2 section here. So means that we already reduce the slab area. So by reducing this slab area, absolutely, okay, so we can reduce the effective depth and also dia punya LX here. Okay, so we can reduce the L over the actual, therefore absolutely our slab will pass lah. Okay, so when you already change the parameter here, so you have to do recalculation, redesign from start. Okay, okay, and then is the crack check. So as a crack check, we have to check for 3. The first one is the slab thickness. It should be less than 200, and then the main bar 3H is less than 400. This is our S maximum 375, and then the actual is 300 that we provided in the main reinforcement. And then here for the secondary bar, okay, we provide also 300, and then the maximum one is 437.5, and then it considered as a pass. Okay, the detailing. So bottom one is the X direction or short span. The top one is for the Y direction for the long span. Okay, so that is actually the example for the simply supported two-way slab. Okay, you have any question or not? So if you have any question, you may ask me now, so that we can discuss and also we can share anything. Because I do already done our example for two-way slab, two-way simply supported slab. For another types of slab, I will, okay, give only a video, and then also this evening I got another class, so I will share another example with another class, and then you may just watch the video and self-learning from that video. Okay, so we will not have an online class for a very long term, long period, so that it will not cause a problem to all of you guys. So if you have any question?
No, sir.
Okay, now I would like to explain about an assignment. So regarding our assignment, so I do already post our assignment in our class assignment here. Okay, you have to submit all your assignment here. So after you complete it, okay. So here is our task. Okay, so our assignment. Tomorrow you will get your assignment. Okay, I do already set the schedule of the assignment should be given by tomorrow. Okay, So you can see by tomorrow your assignment. Okay, here will be the question. Okay, I will show to you the question. So I want you to have your own group. So your group should be not mixed between F1 and also F2 Okay, tolong jangan mix. Okay, it's easier for me to fill up the form marks and marking your assignment. Okay, so students are required to form a design team of 4 to 5 members for the same class group. Okay, given is the structure layout plan for cadangan membina dan menyiapkan sebuah masjid Taman Seri Bayu, daerah Kuala Muda, Sungai Petani, Kedah. So each design team is required to identify and justify the design specification of the reinforced concrete structural element. So you have to determine your own design specification, okay, for every single you can see my sorry, can you see my screen?
No, sir.
No, sir.
No, sir.
Kenapa diam je? Okay, wait. Okay, here is our assignment. I already posted our assignment here. Okay, nanti you boleh buka. Sekarang ni tak boleh lagi lah. Okay, nanti saya akan saya akan edit, saya akan terus post lah. Okay, this is our assignment. Okay, so each of you have to develop your own group. 4 to 5 maximum. Okay, kalau boleh daripada group yang sama. So don't mix the group so that it's easier for me to mark lah. Okay. Here ada question. Boleh nampak
Boleh, sir.
Okay. Jangan diam je lah. Okay, given is the structural layout plan for cadangan membina dan menyiapkan sebuah masjid Taman Seri Bayu, daerah Kuala Muda, Sungai Petani, Kedah. So each design team is required identify and justify the design specification of the reinforced concrete structural element for reinforced concrete slab and beam. So means that you have to determine your own design specification so that you will know where is the value given here is come from. Okay, so you have to determine your own characteristic strength of concrete. Okay, every single information here you have to tabulate the value. Maksudnya you have to do a tabulation. Okay, in this case, okay, you have to design for slab and also for beam. So in one table, okay, so maksudnya in one table you have to prepare design specification for slab and then design specification for beam. Okay, so you just senaraikan lah, okay, all this information here. Okay, yang mana ada for slab, yang mana ada for beam. Okay, so ada yang tak ada. Contohnya for beam tak perlulah ada for variable action kan. So variable action is on slab. Okay, so you have to do lah your own table specification. Okay, so and then the last table, okay, saya nak you buat some justification ataupun daripada mana you dapat that value. Okay, ada any other any references. Okay, so you buat dalam table, so ada 3 kolom lah. Okay, ada 1, 2, 3 kolom. First column is a number ataupun number, second is a specification, the third one is the value, the fourth one is a sources, okay, ataupun references. Okay, ada 4 lah, 4 kolom. Okay, faham Boleh
Boleh.
Okay. So you get it where you get the information, okay, you kena bagi tahulah. Okay. Okay, and then choose one two-way slab and one-way slab from the structure layout plan given from the table 1. Table 1 shows the types of the slab finishes. Okay. Okay, on the slab selection, okay, you boleh pilih mana-mana slab daripada structure layout plan yang attached in the question. Okay, and then you boleh pilih, so contohnya if you are group design team 1, you will combine with team 1 punya semua information lah. Okay, all the information from team 1. Okay, means that your slab finishes is marble. Okay, your simply supported beam is BM1 and also continuous beam is a BM14. Okay, so in a WhatsApp group, okay, someone please create the list, okay, so that which group choose the combination of which one. So means that contohnya group Syakir pilih design team 1, okay, group Akilah design team 2 for example. Okay, so nanti you buat sendiri dalam group WhatsApp so that it will not redundant and then you will not the same part that you design. Okay, so setiap group akan ada lain-lain. Okay.
Okay, sir.
Okay, so ini adalah untuk design which beam that you have to choose for simply supported and also continuous beam. This is a brick wall full height. Okay, this is the brick wall layout specification. Okay, where is the location of the brick wall? Okay, so the brick wall will contribute load on top of your beam. Okay, so let's, in this case along beam M4, okay, sampailah dekat yang 1, 2, 3, 4, 5 cases ni adalah the full height brick wall. Maksudnya refer to table 2 here. Okay, refer to table 2 here, maksudnya dia punya height of the brick wall is full height 3 meter. Okay, yang lain is 1.5 meter height of brick wall sahaja. And then propose, okay, full reinforced concrete design for ultimate limit state and patutnya serviceability limit state here. Okay, nanti I will make a correction. Okay, serviceability limit state for the reinforced concrete slab and also beam. Okay, so you have to do until you draw your own detailing. Okay, submission, save your design calculation in PDF format and compile the work as a design team lah. Maksudnya ketua sahaja yang akan submit nanti. Okay, please submit your design work in a Google Classroom or Microsoft Team of your specific class. Maksudnya in my class only, okay, a group leader sahaja yang akan submit, siapa-siapa lah. So maksudnya kalau ada 7 group akan ada 7 submission in your assignment tu. Okay, maksudnya yang lain tak perlu submit lah. Okay, 0, 0, 0 je lah. Okay, due date is 15 May. Okay, 15 May 2020. Kalau if you have any problem, you let me know. Okay, ini adalah assessment marks. Okay, so total mark for this task is 100 mark, but it will contribute 30%. Okay, 30% of your final marks. Okay, so one way slab 25 mark, and then daripada contohnya you get 75 over 100 times with 30, that is will be your mark. So this assignment 1 we will reveal your mark. Okay, for the assignment 2 we will not reveal your marks. Okay. Okay, this is the rubric that you have to follow. Okay, what are the things that you have to know here? Okay, so you read the rubric carefully so that you can score the full marks 5. Maksudnya if you get 5 over 5, you akan dapat 5 lah. 5, 5, 5 total semua ni, you akan dapat total 100. Kalau you dapat total ni 100, maksudnya you dapatlah total 25 mark tu. Okay, weightage of each task, you dapatlah 25 mark tu. Kalau tak, you akan dapat contohnya macam untuk one way slab akan ada 25 mark, two way slab akan ada 25 mark. Okay, maksudnya you have to score this lah. Every single task tu mesti you dapat 25 mark. So ini adalah cara saya bagi markah lah. Okay, total dia adalah 1, 2, 3, 4, 5 ni adalah dia punya weightage. Okay, so you just read this thing, you just follow, okay, the rubric so that you can score the mark. So please make sure you get a full mark lah. Okay, for your task. So this is the medium that I can help you to get so that you can get a marks lah. Okay, on the test I cannot help you anymore. Okay, any other question on our project or our assignment?
No, sir.
No, sir.
No, sir.
Okay, so if you have don't have any question, okay, if you for this week I will not give any task to you to complete or tutorial because you have an assignment. Okay, so that you have to complete your assignment. So by tomorrow I will share to all of you all the example for the slab, and then you can continue to prepare your assignment. Okay, for next week class, so I will inform you later. Okay, either there is any changes of our class or not, either we will have an online class or not, because it is a fasting month. So if I think that I will have I would like to have a online class, I will let you know. Okay, any other things?
No, sir.
Okay, so if not,
No,
that
sir.
okay. If not, there is that's it for our class. Don't forget, okay, to fill up your attendance. Okay, so I do already attach your attendance. So that's it for our class. Thank you. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir. Selamat
Selamat puasa,
berpuasa.
sir.
Selamat puasa, sir.
Okay.